And in this video, I will discuss on how to find the derivatives of trigonometric function, logarithmic function, exponential function, and how to solve the minima and maxima problem. So, wag na nating patagalin pa. Arat na! But before anything else, in finding the derivatives of any function, you need to know the basic rule first.
This one.
And for the trigonometric function, you need to memorize or at least familiarize the derivatives of trigonometric functions.
The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tan x is equal to secant squared x. The derivative of cosecant x is equal to negative cosecant x cotangent x, while the derivative of secant x is equal to secant x tan x. The derivative of cotangent x is equal to the negative cosecant squared x.
You also need to know the trigonometric identities and simplifying trigonometric functions. The first problem that I create is the y is equal to the square root of sine squared 4x plus 2x squared all over cube root of cosine squared x plus 4. And find the first derivative of it. The first thing to do is to apply the quotient rule, which is the first derivative of y is equal to g f prime minus f g prime all over g squared. From that formula, you just need to substitute your given. So, your f will be square root of sine squared 4x plus 2x squared, and g is the cube root of cosine squared x plus 4. Now, the first derivative of y is equals to cosine squared x plus 4 raised to the power of 1/3 times the derivative of our f, which is the sine squared 4x plus 2x squared raised to 1/2 minus f, which is the sine squared 4x plus 2x squared raised to 1/2 times the derivative of cosine squared x plus 4 raised to 1/3 all over g, which is the cosine squared x plus 4 raised to 1/3 raised to the power of 2. In finding derivatives of trigonometric function, you need to use the basic rule in the chain rule. So our equation will be the square root of cosine squared x plus 4 times 1/2, copy the inside function, raised to 1/2 minus 1. And derive the inside function. And just do the same to your next equation, and do not forget to over it with your g squared. Now, we will apply the rules in finding the derivatives of trigonometric function. So, the derivative of sine squared 4x plus 2x squared
Is 2 sin of 4x cosine 4x times 4x plus 4.
and let's put in the denominator the equation that has negative power to make it positive. And just do the same on the other side and copy the rest of the equation. Apply the rule in finding the derivative of trigonometric functions. So the derivative of cosine squared x plus 4 is 2 cosine x minus sine x plus 0. Note, any derivative of a constant is 0.
All over 3 of cosine squared x plus 4 raised to the power of 2/3. Remember that we put this in the denominator to make its power to positive. And do not forget to over it with your g squared.
In simplifying the power of a power, just multiply them. So the power of 1/3 times 2 is 2 over 3. Now, we need to simplify our equation. In simplifying trigonometric function, we need trigonometric identities in order for us to derive the correct and simplified form of a problem in the equation that we have.
2 sine of 4x cosine 4x from trigonometric identities that 2 sine t cosine t is equal to sine 2t. We can now have sine of 8x and just copy the rest of the equation. And for the other side, just do the same. 2 cosine x negative sine x is equal to negative sine of 2x, and just copy the rest of it.
Now, let's multiply the equation that can be multiplied. So, let's multiply sine of 8x to 4 plus 4x and copy the rest of the equation. In multiplying it, we get 4 sine of 8x plus 4x, and the subtraction become addition because a negative multiplied by negative is a positive. Now, let's simplify it further by adding these two equations. So, we got this one, and let's get the reciprocal of cosine squared x plus 4 raised to the power of 2/3 to multiply and simplify. Now, we get this equation. Now, we have an equation that can be multiplied. So, let's multiply and get this one. And to simplify it further, we have
6
cosine squared of x sine
x plus 6 cosine squared x plus 24 sine of 8x plus sine of 2x sine squared 4x plus 2x squared sine of 2x all over 3 sine squared 4x plus 2x squared raised to the power of 1/2 times cosine squared of x plus 4 raised to the power of 4/3.
X is for the logarithmic function.
The second problem that I create is to solve the first derivative of g of x is equal to the natural logarithm of cosine 2x all over 1 plus x. The first thing that we need to do is to differentiate using the derivatives of logarithm, which is f of x is equal to 1 over f of x times the first derivative of f of x. To solve this kind of problem, we need the reciprocal, so the denominator becomes the numerator and vice versa, multiplied to the derivative of your original problem. For us to find the derivative of cosine of 2x all over 1 plus x, we need to use the quotient rule. Since we have 1 plus x over cosine of 2x, we will multiply have 1 plus x to the derivative of cosine of 2x minus cosine of 2x times the derivative of 1 plus x all over 1 plus x squared. Now, let's simplify by using the trigonometric rule. So the derivative of cosine of 2x is negative sine of 2x times 2, and the derivative of 1 plus x is 1 plus 0. Now, we get 1 plus x times the quantity of 1 plus x minus sine of 2x times 2 minus cosine of 2x times the quantity of 1 plus 0 all over 1 plus x. 1 plus x, we just factor the 1 plus x squared all and we over it by cosine of 2x. We can cancel out the 1 plus x that can make the equation negative sine of 2x times 2 plus 2x minus cosine of 2x all over 1 plus x multiplied to the reciprocal of cosine of 2x. Now, we have the first derivative of g of x is equals to negative sine 2x times 2 plus 2x minus cosine of 3x all over 1 plus x times cosine of 2x. To simplify it further, let's multiply negative sine of 2x to 2 plus 2x and 1 plus x to cosine of 2x. For the final answer of the derivative of g of x is equal to natural logarithm of cosine 2x all over 1 plus x is equal to negative sine of 2x minus 2x sine of 2x minus cosine of 2x all over cosine of 2x plus x cosine of 2x. For our exponential function, our problem is to find the first derivative of y is equal to e raised to the power of x plus e raised to the power of negative 3x all over e raised to the power of 3x plus 1. In solving the derivative of exponential function, we need this one. The rule in finding the derivative of exponential function. And to solve our problem, we need the quotient rule. We will apply first the quotient rule. So our f will be the numerator, the e raised to the power of x plus e raised to the power of negative 3x, and our g will be the denominator, e raised to the power of x plus 1. So our equation will be the first derivative of y is equal to quantity of a raised to the power of 3x plus 1 times the derivative of e raised to the power of x plus e raised to the power of negative 3x, subtract by the quantity of a raised to the power of x plus e raised to the power of negative 3x times the derivative of e raised to the power of 3x plus 1 all over e raised to the power of 3x plus 1 squared. Next, we will apply the rule in finding the derivative of exponential function. So, the derivative of f will be e raised to the power of x plus e negative 3x times negative 3. The derivative of the g, 3 e raised to the power of 3x. Then, copy the rest of the expression, the value of f and g. This time, we will simplify first the derivative of f and g. Next, we will multiply e raised to the power of 3x plus 1 and e raised to the power of x minus 3 e raised to the power of negative 3x, subtracted by the product of e raised to the power of negative 3x and e raised to the power of 4x plus 3. And we have now negative 2 e raised to the power of 4x negative 6 plus e raised to the power of x minus 3 all over e raised to the power of 3x. We put e raised to the power of negative 3x to the denominator to make the power to positive and all over e raised to the power of 3x plus 1 squared. And now we will reciprocal the denominators. Now we have e raised to the power of 3x times negative 2 e raised to the power of 4x minus 6 plus e raised to the power of x, and its product will be negative 2 a raised to the power of 7x minus 6 raised to the power of 3x plus e raised to the power of 4x minus 3
And the denominator will
e
be
raised to the power of 3x times e raised to the power of 3x plus 1 squared. Therefore, our final answer will be the first derivative of y is equals to negative 2a raised to the power of 7x plus e raised to the power of 4x minus 6 raised to the power of 3x minus 3 all over e raised to the power of 3x times e raised to the power of 3x plus 1 squared. In solving a minima or maxima problem, we have a fourth step. First, we need to illustrate it, if it can be illustrated. Second, single variable. You express one variable using other variable in terms of their relationship. Third, the first derivative of y is equal to 0. Set the first derivative of y is equal to 0, so we can now get the value that we maximize or minimize. Last, solve for the values. Our problem and minima or maxima problem is this. A rectangular lot adjacent to a highway is enclosed by a fence. If the fencing costs $2 per foot along the highway and $1 per foot on the other side, find the dimension of the largest lot that can be fenced of $600. The first thing to do is we will illustrate the said problem. Note, one of the sides of the lot is adjacent to a highway. So let's say that this is the highway. And it said in the problem that if a fencing costs $2 per foot along the highway, thus we only have one side. So this is the only one that we will multiply by 2. So it
the equation is
becomes 2x, thus all sides which cost $1 foot. So we will add them all and we can now get 2x plus 1 times x plus 2
y.
is equals to 600. To simplify it, let's add the 2x and x that give us 3x. Then express everything in terms of one variable. So in terms of one variable, we can now solve for y in terms of x. That is 2y is equals to 600 minus 3x all over 2. Then to simplify it further, we have y is equal to 300 minus 3x over 2. What are we looking for is the dimension of the largest lot. Therefore, we have the area of rectangle, which is a is equals to x times y. Now, we will substitute the value of y which is to 300 minus 3x over 2. Now, our a is equals to x times 300 minus 3x over 2. To simplify it, we have 300x minus 3x squared over 2. After this, we will differentiate the equation. Now, we have 300 minus
6x
over 2. Then, set the first derivative to 0. Then, we can now solve the value of x. So, 600 is equals to 6x. The value of x will be 100. Now, we can solve the value of y, which is 300 minus 3 times the x, which is 100 over 2. Next, we have 300 minus 300 over 2. Then 300 over 2 will give us to 150. So now y is equals to 300 minus 150, and the value of y is 150. Therefore, the dimension of the largest lot is 100 feet times 150 feet.